Okay, so let's move on to the challenge problem of chapter 15, Intro to Algebra. So the first is find all ordered triple integers. Okay, first is integers that satisfy this one. So you can see, because I mean the x plus 5, they are all integers, right? So this x plus 5 also belong to integers, and the y minus 2 also belong to integers, right? And the z plus 3 also, the square, right? The all square is belong to a per integer square, right? So these are all belong to the positive integer or uh, or 0, right? So now you can see, because it is equal 1, right? There is only three possibilities: 1 0 0, and 0 1 0, and 0 and 0 1, right? So now let's set the solution to each of them, right? It's a 1 0 0, so this one must be 2 and negative 3, and in order to give 1, it's plus minus 1, right? If plus 1 is negative 4, and then minus 1 is negative 6. Okay, so that's the first solution. The second one is negative 5 and negative 3. Okay, now we can see if this is the 1, so it could be 1, or it could be 3. Okay, negative 1 and positive 1. And the final one will be negative 5 is 0, and 2 will be 0. Then it's 1 will be negative 2, and if negative 1 will be negative 4. Okay, so that's all the solutions we can have. Okay, we have 6 solutions. So this one is for the real number xyz. So then what is y plus z? So if the square is greater or equal than 0, is square greater or equal than 0, then equal 0 means x minus y equals 3, and the x plus the z equals negative 2, right? So this is the 1 and this is the 2. You use the 2 minus the 1 is the y plus z is equal to the negative 5. So what value can satisfy this inequality? Okay, so we can see x squared minus x minus 1 is 0. Okay, so the delta is less. This one we know it's open up, right? And the center is at the negative x equal to the negative of negative 1 over 2. So it's 1 over 2. So the center is here, and then we want to solve whether this one have the intersect with the intercept with the x-axis, right? That's the roots. So let's do the delta is b squared plus 4, so it's 5, right? Greater than 0, so yes, there is a root. So x equal to the 2 of the 1 plus minus negative 5 as root 5. So root 5 is 2 point something, right? So that's why we have a negative roots, and we have another positive roots. So this is the it looks like. Okay, and so we want the x squared minus x minus 1 is less than 0, right? So now we know we shouldn't take this one, so the range of the x, okay, is between here. So when the x is greater than the 2 1 over 1 minus root 5, and less than the 1 plus root 5 over 2, right? So in this range, we will get the negative value. Next. So if this one is less than 0, and we have the p equal this, what are the possible value of the p? Okay, so now let's draw a picture. Okay, so x, y. So this one is the x squared minus 5x the plus the 6 is equal to the x minus 3 and the x minus 2. So we know there is a root of the 2 and there is a root of the 3, and this is the symmetry is in the center, right? It's 2.5. Then we know it will looks like this, right? And for the p equals this, so p is equal to the x plus 2 and x plus 3, right? So we know it has the roots of the -3 and -2, so it's -2 and the -3. Then the symmetry line is here, right? So it will be like this, okay? But we know our x range, okay, because we need to satisfy this, right? So the x range should between here and here, okay, exclusive, okay, because we need less than 0, right? So that's this section. So we know here, so you can see our range of the data of the p is small. It should be great. So the p should greater than the p of the 2, x equals 2, less than p equals 3, right? X equals 3. So the p of the 2 is 2 plus 2, and the 2 plus 3, so it's equal to the 20. The p of the 3 is equal to 3 plus 2, and the 3 plus 3 is equal to 30, right? So the p should be greater than 20 and less than 30. Next. So find all the values of the k with greater than 0 consist a single interval possible finite infinite on the number line. Okay, so let's see if it's greater than 0, how could it be? Okay, so let's see the k doesn't equal to 2 and not equal to 5. Okay, so if k is not equal to 2, not equal to 5, so we can say without loss of generality, right? Let's see, just say k is greater than 5. Okay, so now we have we divide the whole thing into several segment, right? So here is the 2, 5, and the k, right? And we can see this is the A, B, C, right? Okay, now we can list the A, B, C. Okay, list the A, B, and the C. Okay, so we know for the less than 2, right? Everything is everything is negative, negative, and negative. Okay, and here is greater than k is always positive, 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 right? Then this is after the final is the multiplication, right? Okay, and between the 2 and 5, right? So we have the positive and negative, right? 5 is the positive, positive, negative, right? Okay, now we can see, okay, so we want it to be greater or equal than 0, only have one single intervals, right? So here is the negative, doesn't count. Here's the positive, count. Here is the negative, doesn't count. Here's positive, count. So see, we have two different segments that can cause in the positive, right? So there's no way to do it. So you can see the k must be equal to 2 or k equals to 5. Okay, otherwise it doesn't work. Now let's see, this is the case 1, right? Now let's see the case 2. Okay, the k equals 2, then we have x minus 2 squared and x minus 5, right? We know this one is always greater or equal than 0, right? Then we see this one, now we see this one, right? So we have the, okay, now we have the, if x is less than 5, right? If x is less than 5, right? Or x or greater equal than 5, right? If x greater or equal than 5, right? So we know the the p will greater equal than 0, right? But if x less than 5, right? But x equals 2, x less than 5 and x equals 2, then we can see the p also equal to 0. So that's why we still have two intervals, okay, that can satisfy this if k equal 2, so it doesn't work. Now the only thing, the final case is case 3. So k equals 5, x minus 2 and x minus 5 of the square. So this one will be always positive or greater or equal than 0, right? So now let's see if x less than 5, this one will be negative. X greater or equal than 5, this one will be positive. Greater or equal than 0, right? I mean non-negative. That means this one work. So the only thing work is k equals 5. So next is we want to see is that this expression has the minimum value, right? For this one, you can see we have 5x plus 2 and x plus 1. We can always do the 5 of x plus 1, then minus 3 is x plus 1. So it's 5 minus 3 over x plus 1, okay? So now apply this one back. So we have 5 minus 3 x plus 1 minus 5 of the square plus 10, right? So let's see, this is the f of the x. This is f of the x equal this. So we have the 9x plus 1 of the square plus 10, right? So now you can see if this one, right? This one, if x goes to the negative infinity or x to the infinity, right? And the minimum value, right? This one can approaching to 0. But can never be 0, right? So there is no minimum value, because if you think there is a small value and you increase the x, you can get smaller, okay? So there is no minimum value, okay? And because you can approach into 10, infinitely approaching to 10, but no, you cannot equal to 10. Next, if x is real and this one, then what is the complete set of the x for which y equals to 0, okay? If y have real solutions, okay, 4y squared plus the 4x of the y plus the x plus the 6 equals 0, right? We want to find the y has the real solutions, means the delta, this is the quadratic of the y, means the 4x squared minus the 4 of the 4x x plus 6 is greater or equal than 0. Then that means x squared, take out 16, okay, minus x and x plus 6 is equal to, is greater or equal than 0. Then what do we have? Then what we have is the x squared minus x squared minus 6x is greater or equal than 0. So x is less equal than 0. Huh? Let me see. 4x squared minus 4. Okay, I'm sorry. Here's a 4. So here is the 16. So we have the x squared minus x minus 6 is greater or equal than 0. Then we have the x minus 3 and x plus 2 should be greater or equal than 0. All right. So it opens up this one. So x and the y, so the roots is the negative 2 and the positive 3, right? So it's the 1/2 is the center, so it's something like this, right? Okay, so we want this one to be greater or equal than yeah, we want this one to be greater or equal than 0, right? So we have to have this range and this range. So the range of the x should belong to the negative infinite to negative infinite to -2, and union the 3 to the infinite, positive infinite. Okay. So in this problem, we are going to investigate inequality slightly stronger than the AMGM. Okay. So A, B, C, D are positive. So we have the, for example, is the 10. Okay. So means the A and the B is 5, and the C and the D. Okay. So you can see how we can get the 10, right? So we can, if A is equal to 10 minus delta, then B must 5 minus delta, the B must be equal to 5 plus the delta, right? So that's why you can see A and B, if A and B are further away, means it just diverges more from the center of the 5, right? C and D are closer. So we want to show the AB less than CD. Okay, so without loss of generality, we can also say A is less or equal than 5, and B and C is less than equal than 5, right? And the B is here, and the D is here. So now let's see the AB. So A times B, B is 10 minus the A, right? And we compare with the C times the 10 minus C, right? So we compare the A times 10 minus A square, compare with the C times 10 minus C square, okay? Because we know it's A less than C, right? So we compare with the C minus A and the C plus A, right? Move this one here, and the 10 times the C minus A. Then basically is compare the C plus A and compare with the 10, right? So we know the C and A both are less or equal than 5, right? And the A also less than C, right? So we know at least one of them should be less than 5, right? So that's why we have the A plus C should less than 10, okay? So if this is the case, you can see AB will be less than CD. Okay, next is the 10. So you can see we have nothing special with the 10, right? Basically, you can draw is the AB, and you can say A plus B equals the C plus D equals the 2m, right? So the center will be the m, right? Is how far your divergence from the center, okay? So now you can see in general A times B is m minus the delta, and m plus the delta, right, equals m square minus the delta square. So as the delta is larger and larger, right, the multiplication becomes smaller and smaller, right, in this case. So you can see there's nothing special with the 10. So next is if the two positive integer has sum of this, okay? So now you can see the C, if A plus B and is 365, and the A, B are positive integers, okay? So to make the A times B smaller, right? A times B smaller, you need to be AB as much as divergence to increase the delta, right? So the biggest delta could be A is smallest one, and B is 364. So 364. The final one is which is larger. Okay, so we can see let's draw them together. Okay, so for the D, you can see we have a center at the 5, 4, 3, 2, 1.5. 5, 4, 3, 2, 1.5, right? So we have the 5, 4, 3, 2, 1, 5, 4, 3, 2, 2, and 5, 4, 4, 3, 2, 0, and 5, 4, 3. It's the 1.5, 1.5, 3, 2, 3, right? So the sum of these two is the same. The sum of these two is the same, right? So now you can see, in order to have the further the divergence is, the less the multiplication is, right? So now you know 5, 4, 3, 2, 0 times the 5, 4, 3, 2, 3 will be less than 5, 4, 3, 2, 1 times the 5, 4, 3, 2, 2. Okay. Next, so can we show this for all the, so first is x and the y is belong to the positive or the 0, right? Greater or equal than 0, we want to prove this. So let's do the square, okay? So 2x squared plus y squared compare with the 4 of the x squared plus y squared plus 2xy. Then we compare this one equivalently is 4 the x squared plus the y squared with the 4 of the 2xy. Then it's equivalently to compare the x squared plus the y squared minus 2xy compare with the 0. So we know this is the perfect square. X minus y squared will be greater or equal than 0. So that's why you get this. Okay, so what must be true of x or y in order to for the two sides to be equal, right? So if you can see, if equal 0, x must equal y. That's the B. Okay, next. So we want to use previous problem to show this, right? So we know the x squared plus the y squared over 2 will be greater or equal than the 2x plus y. That means the x squared plus the y squared will be greater than 2 of 2x plus y of the square. Right, so we can see this one is 1, 2, 3, 4, 4 square plus 1, 2, 3, 4, 6 square greater than 2 of the 2, 1, 2, 3, 4, 4 plus 1, 2, 3, 4, 6 of the square. So it's equal to 2 times 1, 2, 3, 4, 5 square. Okay. And also we know is the equal sign is the x doesn't equal y, right? So the equal sign doesn't work. Okay, so that's why. Next, let a be a real positive real constant. So a is belong to a positive real constant, and the minimum value of this expression is 72. Okay, so let's do the minimum value of this expression. Okay, so the minimum value of this expression, it will be, let's see, it's the x squared plus a over 2 of the x, right? Then we plus the a squared over 4 over 16. Okay, then plus the 2 of the y squared minus a over 2y, then plus the a squared over 16, then we plus the 8 over 6a squared, right? So now it's the p of x and the y equal 2 of the x, then plus the a over 4 of the square, then plus the 2 of the y minus the a over 4 of the square, plus the 3 over 4 a square. Okay, so now we see what's the minimum value, because this one is greater or equal than 0, this one is greater or equal than 0. So the minimum value, the p min, is equal to 3 over 4 of the a square. We know this one is equal to the 72. So now we can try to calculate the a is equal to plus minus the root 72 is 3, 8, and 4. Then it's plus minus of the 4 of the root 6, right? Because I mean we are talking about a belong to the positive real, so a is 4 root 6. Okay, next. So compute the largest value satisfy this. The largest value of x. Okay, let's do this. Let's see what's this quadratic form is. It should be somewhere like a circle, right? So x minus 5 of the square plus the y minus 4 of the square is equal to 8 plus 25 plus the 16 is equal to, there's a 49. So this is a circle with the center of the 5 and 4, right? And the radius of the 7, right? So what is the largest x? It must be this point, right? From here at the radius of the 7. So x of the max should be equal to 12. Okay, the last one. So this one is let's see. Okay, this one is a cyclic. Okay, so x minus y of the square plus the y minus z of the square plus z minus x of the square is greater or equal than 0. So we have expanding is 2x squared plus 2y squared plus 2z squared greater or equal than 2xy plus the yz plus the zx. So in this case, then you have the x squared plus the y squared plus z squared greater or equal than the xy plus yz plus zx. If the equal sign is established, means this is 0 and 0 and 0. So the equal sign means x equal y equals z. Okay. So yeah, that's it for all these chapters. Thank you. Bye bye.